Okay, welcome back. So what we are going to do now is we're going to look at the schedule. Okay, the schedule. You can do schedule with this. Okay. So let's look at the schedule. Let's say we want to generate some schedule for Babini schedule for our beams, for our columns, and for our walls. Okay, let's look at that. So you click on schedule management, and you come here. So here you're going to see concrete beam schedule, concrete column schedule, and concrete wall schedule. Okay. So let me quickly first take the concrete beam. Okay, then click on art, click on contents. What are the contents I'm looking for? I need all the content of the beam. Okay, so you just drag that here and okay, then view. So let's look at this quickly. All right, so first let's go through here. Concrete beam schedule. Okay, this is the name of my whatever I'm doing here now. Okay, so concrete beam schedule. Let's look at that. So you come here, you now come to CRB 111. So this is the first beam, okay, on my design. So and this is the reinforcement detail for each of it, just like the way you're seeing it. And this is the detailing for my links, okay, for the stirrups. So this is it. All right. And then this when you come to the revision note, you're going to see first span 68 beams in group. So this easily groups all the beams just for you to know how many beams are having these same details. Okay, just the same thing all through, the same thing all through internal span. So once you're able to identify the beam, okay, just you now begin to count how many of them are in that detailing group. Okay, then here you have your bar bending schedule. Okay, your bar bending detail. This just give you the concept of how you're going to do your detailing. It may not be very precise the way other software does, yes, okay, but this is how this is how Tekla, the structural designers, arrange the steel bar. Okay, so you can just go through this. So for each of these nodes, you just come below here, bar bending schedule, beam schedule notes. Okay, for each of the notes, you just take note of all the notes you're seeing here from 1 to 6. From 1 to 6 note, these are all what it means. So you just read each of the notes, okay, from 1 to 6. So that is that. All right, so the next thing I'm going to be looking at is let's go back there. I'm going to be looking at concrete column schedule. Let's try this too. Let's see what happens. Pick everything for me. Okay, and view drawings. Okay, few minutes. Let's look at how this one going to look like. Okay, so this is the schedule for your columns. Column detail. Okay. Okay, let's see how it looks like. Not really detailed. Not really detailed, but just telling you for each of the floor is the same thing you're going to be having all through. Okay, that's why you're saying as below, as below, as below. So this is going to be what you're having here is going to be as below, just the same way you have here. The same thing all through. So for each of this floor, it's going to be just the same detailing, just the way you're seeing here. So let's check if there is any more detailed thing. Not really. So but this is the grouping. Here is the grouping, okay, for all the columns. Here is all it is the grouping for all the columns. And okay, we've seen this before. Okay, total material weight. We've seen that before. Okay, let's see check again. Let's go for wall. Okay. So for wall, let's open this. Let me be looking at this wall, this wall, this wall. Let me just pick few walls, okay? Then view drawings. Let's see. Okay, so you can see the walls, okay? For each of these walls is W6. Okay, so okay, let me start with W4. So W4, this is the height where this wall is. This wall is at 3.2 meters height, okay? Okay, so this is the height of this very wall, okay, but this is the cross section. So then you can see the dimension for the cross section of the wall, and you can see all the bar detailing. B is for, you can see B here, you can see C, and you can also possibly find the A. Okay, so this is it for the beam section, for the wall sections. Okay, all right, so when you now come here, You can also see the quantity of H10. Let's say this is the bar mark. This is the type of bar. That's the diameter of the bar. Quantity is 156 of this. Okay. Then the total length, the length for each of this is 1675. Okay. So total length for 156 quantities of Y10 for this bar mark is 1675. All right. So that is that for one. Then if you now see total length for in meter, this one is in millimeters. So total length in meters is 261.3. Okay, so 261.3 is for 156. 1675 is just for one. Don't forget this is 156. So for one of these is 1675. So for 156 total length is 261.3 meters. Okay. So this is for W4, W6, W9. So this is still easy for you to generate your bar band. This is your bar bending schedule. Okay. It's that easy too. All right. So quick one. I want to do a report for this. So let's go to report this time. I want you to show me all the reports. I want to see all the reports. So give it a few minutes to load. Still loading. All right. The report is ready. So to make it easy for you, just take it to PDF. You can convert it to PDF, send to PDF. You can send to Word, you can send to Excel, you can send to Tekla. Okay. So you can also control next page, previous page. Okay. So let's go back to first page. So this is first page. You can also control your page setup, but we are not looking at that now. Let's send it to PDF. Small the result are out of date. Do you want to continue? Yes. Few minutes. Let's send it to PDF. Okay, we're almost there. We're almost there. Okay, we are here. Okay, so you can see the report for my beam design. Okay, this is the table of contents. All right. So when you look at this report quickly, you're going to see two beams are failed here. Okay, two beam failed. All right. I didn't have time to go through it. So two beams failed. You can see that, and you can see all the rest that I've passed to. So when you now come down, let's look at this one after the other. Uh, okay. So and this is critical span. This is critical span. Just capture critical span and just do the detail. That's why you're seeing a critical span. Maybe because of the loading and the span. But let's look at this quickly. This is the combination. Okay. This is under combination load. Combination load is I designed it based on the ultimate limit state factor. All right, so you can see the moments for this very beam you're seeing here. Okay, this is the moment here. This is also the moment here, and you can see your effective depth. Okay, which is your D here, 502. You can see your D2. Okay, you know what D2 is. D2 is from your top to the middle of your top bar. Okay, from the face of the concrete to the middle of your top bar. So that's your D dash normally in your design. All right. So we also have K all over K prime. Okay, K all over K prime, and you can see the different factor, and you know what the code says. If it is more than 0.156, if you're using the BS code, you should be designing for both the compressive and tension zone of the reinforced concrete member. Okay, so like here, you can also see that. You can see your lever arm Z 675. Okay, you can see your lever arm, and then you can also see what again? Area of steel required. Let me zoom this in a little. Okay, area of steel required is this. Okay, area of steel required is this for this moment. Then area of steel required for this is this. All right. So area of steel required. This ones are not necessary. Okay, so area of tension steel is this. Area of steel minimum, just like from your code, 0.13% BH. This is the minimum area of steel, okay, based on the section. So, but now, this is your area of steel required, and this is the area of steel provided by the software. So these are some of the things you need to pay attention to. When you look at the area of steel required based on the design and the area of steel provided, it's huge. The difference is actually huge, so much. And if I'm using Y12, Y16 for instance, I think Y16 is 301 point something. That is the square area of Y16. So two Y16 can still go well for this area of steel required. Two Y16 can go well for this, okay? Or 3Y16, let's say. Okay, 3Y16, because if you check the diameter of 3Y16, the cross-sectional area, I think it should be, if I'm not mistaken, I think that should be 201. I think so. 201 point something, okay? So if that's the case, then for this reason, we are supposed to be using 3, but in this case, it's using 2H20. That's why you're having this area of 2 provided, okay? Just for the entire, for the two fixed end and for the mid span, okay? So that's that. And let's just go down a little. Design summary bending bottom. What was the other one? Design summary bending top. So when you see here, there is no need for the top reinforcement here. Okay. We only have top reinforcement where we have the support. That's the only place you have the negative reinforcement. If you draw your bending moment diagram, you're going to see. So you don't have any business here. It's only at the bottom you're going to be having reinforcement here. And at the bottom, we don't have any need for this because there are no negative moment at the support, only the span moment. So this is very simple. That's why I always, advise if you want to learn how to use software for design, you must know how to do the manual calculation with hand first, so you can understand every detail the software gives you. So I think I've analyzed everything about this for you. I've analyzed everything. You know what D is. You know what D2 is. Normally in your design is D dash. All right. And you know what K all over K prime means. Everybody knows what that means already. And that AST required, there is nothing here because there is no moment here. Okay. We're only dealing with the span moment. So area of steel for the middle span is this. Area of steel for this is also 0. Okay. So area of steel required at the end of the day, area of steel provided is this because definitely the same reinforcement will just go across the entire span of the beam. You're not just going to stop this at the middle, so you just drag it all through. Okay. Then you see the deflection check. Okay. Deflection check is passed too. Okay. Then for shear and torsion, I don't think I have any issues with torsion because it's cast alongside with slab. Okay, so there won't be need for any torsion because there's no room for rotation. Okay, but you can also check out the shear. Okay, you can check out the shear for the member, and what again is here. Okay, the minimum shear required, and you can also see the shear provided. So here you can see the reinforcement detail for the shear. Okay, so the maximum shear this member can take is this. Okay, this is the maximum shear for this member. So the calculated shear is this, so we are good to go. All right. So we just provide this because definitely we need shear links. Okay, but in terms of shear, the member is good. All right. So that's it. So you now move on to the next member. All right. So I will not be dwelling too much on this. Let me see if we can go quickly to columns. Let's go quickly. Okay, column design. This is column design. Let me zoom this. Column design. All right. Let's start from the beginning of the column design. Okay, this is steel beam. This is the beam detailing, okay? So design summary bending top. This is steel beam. I'm looking for, okay, column. So this is column, okay? All right. So we are good to go. So column design, CRC2, okay? Number in group, there are 52 in that group. Critical member is C56. So the software can tell you which of the member is more critical. The member may be critical not just because of the axial load. It may be also as a result of the moment. In fact, it's really because of the load, the axial load on the member, and the moment on that member. Okay, so that is it. So the section is here, the grade of concrete is here, maximum utilization ratio is this, then status pass. Okay, so let's just look at it. This is the very column we are talking about now. All right, okay, so this is it. Column, there is no much detail designed for it. And this is your wall. This is wall. This is utilization ratio. Okay, and you should always be careful with your utilization ratio. If it is too much, then you have to see play around with your design. Okay, you have to do an economical design even when you're thinking of safety. All right, let me check again. Where is slab? Okay, I think I have one slab here. All right, so let's check for slab. This is panel. Okay, let's look at panel S1751. Okay, so this is the reinforcement provided. Area provided is this. Area required is actually this. Okay, so but this is what the software provide because it must always be greater than your required. Okay, so this is it. This is it for all the slab. Okay, so you can go through them one after the other. So everything about your design is here. Then finally we come to pile capacity. Ooh, we're here now. Let me look for the beginning of this. I didn't want this video to be this long. This video is too long for me. Let's check this out. Sorry, I'm looking for the values. Let me go through this again. Mm. Okay, so pile capacity summary. All right. So this is for the pile cap. Okay, this is for the pile cap. So first we need to find out which of the pile we are designing for. Let's check here. B1 slab mat panel. So this is it. S1668. Okay. So you now come here. Reinforcement provided is this. Okay. You can see area of steel provided. Don't forget this is your pile cap. This is your pile cap. Then area of steel required. So area of steel required is 38. Oh, this is actually very small. Utilization ratio is also very small. Okay. All right. So maximum value for bearing pressure check. Maximum value is 28. And the limiting is 100 kilonewton. Okay, so this is the ultimate is the limiting value is 100. Okay, based on our soil bearing capacity. Okay, but this is the maximum based on the design. Okay, so this is still good. Then you can see critical combination. This is the critical combination for the foundation design, 1.35 for your dead load and all of that. Okay, so that's just that for the design. Very simple and straightforward.